Hi everyone! Today we're going to learn how to calculate TPN. To start, we'll need to remember some things first. When you have something like an fill-in-the-blank percent solution, let's say a 10% solution, that means that the solution contains that number of grams of the compound in 100 mils or 1 deciliter of the solution. Thus, a 25% dextrose solution contains 25 grams of dextrose in 100 mils or 1 deciliter. That means it's 250 grams in 1 liter. In our first example, we have a solution that is running at 50 mils per hour. It is a 2-in-1 solution, meaning that it contains both dextrose and amino acid in the same bag. First, calculate the total volume. So 50 mils per hour times 24 hours in a day gives you 1,200 mils, which is the first step here. The next step is to get the calories from dextrose and also the grams of dextrose. So we take the total volume of the solution, because remember, dextrose and amino acid are present together, and we say 1,200 mils of this 2-in-1 solution times 25%, so 0.25, gives us 300 grams of dextrose coming from that solution. And we remember that it's 3.4 calories per gram of dextrose because of an anomaly in the hydrated dextrose molecule. So 300 grams times 3.4 calories per gram gives you 1,020 calories from dextrose. Next, we calculate the calories and grams from amino acids. So again, it's a 2-in-1 solution. 1,200 mils of this dextrose plus amino acid solution times 0.1, 10%, gives us 120 grams of protein. And 120 grams times 4 calories per gram for amino acids gives us 480 calories from amino acid. Next, we do the lipids, 10 mils per hour. There's an FDA rule that says that lipids should not hang for more than 12 hours due to risk of contamination. So 10 times 12 hours would give us 120 mils from lipids. Lipids actually come in 100, 250, and 500 mil bottles. So in this case, you actually might want to consider either using 100 mils if that's possible, or if you want to provide a bit more lipid, but this is the example given. So 120 mils times 2 calories per mil, this is 240 calories. And remember, lipid is a little bit different. It's not 9 calories per gram, it's 10. So 240 divided by 10 gives us 24 grams of lipid. To get the total calories, we just add up the calories from each macronutrient. So 1,020 from dextrose, 480 from protein, 240 from lipid, and that gives us 1,740 calories. And then if we want to go ahead and calculate the percent from each macronutrient, we could do that by taking the, let's say, 1,020 divide by 1,740, the total, and that gives us about 57% of calories from dextrose. 480 for protein divided by 1,740 gives you 28% protein, and then the 240 divided by 1,740 gives us 15% lipid. So you can see this in this example, the lipids are a little bit below the AMDR, but there might be good reasons to do that when you're giving TPN. In our second example, we have an order that's given not as a 2-in-1 solution, but it's actually separately listing the amino acids and the dextrose. So it's a bag of 70% dextrose, which is one type of standard dextrose solution, and a bag of 10% amino acid, and then you might mix those two together to make a 2-in-1. So in this case, you take your protein amino acid solution and you have 750 mils, and then you multiply that by 10%, so 10 grams divided by 100, which gives us 75 grams of protein, which we multiply by 4 to get 300 calories from protein. Then with the lipids, again, in this case we know our total volume, so they're going to be using a 250 ml bottle, but 225 mils, and 20% lipid we just know is 2 calories per mil, just like 10% lipid is 1.1 calories per mil. and that gives us 450 calories from lipid. And then for carb, we have the 315 given solution times 70% gives us 220 grams, and we multiply by 3.4 and get 748. If we add these three numbers, our 300, our 450, and our 748, we have come up with 1,498 calories and 75 grams of protein, and you could calculate the percent from each macronutrient if you wanted. Our final thing that we're going to talk about is how to calculate a TPN order for a patient who needs one. So of course, first, step one would be determining their actual energy and protein requirements. In the ICU environment with a critically ill patient, it's always recommended to use indirect calorimetry, but if not, you can use a predictive equation. The evidence analysis library suggests using Penn State if someone's critically ill. The Aspen guidelines say use whatever you want, just stick with a particular approach. And then protein, remember, you calculate in grams per kilo, almost universally based on your actual body weight, except in obese patients where there's a different guideline through Aspen. And you decide the grams per kilo based on their disease state. Step two is you decide if lipid will be needed. And remember, the answer is no if they're on significant propofol. Remember, propofol is delivered in a 10% lipid solution. So if they're on a significant rate of propofol, they should not need extra intralipid. If they have severe egg allergy, or if they have triglyceride greater than 300, or if they're critically ill and they aren't expected to require PN for more than 7 days, they would be considered at low risk for essential fatty acid deficiency. The risk of lipid would probably outweigh the benefit, and so you wouldn't give it in those cases. Then you determine your desired volume. If they're on a fluid restriction, you're going to restrict yourself totally for the parenteral nutrition to 1,000 mils, 1 liter. If there's no fluid restriction, then you can use a predictive equation. But you might subtract from the amount available to you if they have significant IV meds or other things going that would give fluid. Also, even though lipids are non-aqueous, they're often subtracted from the total volume available in the ICU environment. Now you have to determine the volumes and concentrations and or distribute the calories for macronutrients. I like to start with protein first because we kind of prioritize protein in the ICU. So first I subtract the kcals from protein from the total energy that's recommended, and then if the lipids will be provided, I decide the percent energy from lipids and subtract those, and then the remainder comes from dextrose. Now we subtract the lipid from the total volume recommended, and then we determine the total volumes and concentrations. So we would subtract lipids from recommended volume. That will provide the volume for dextrose. Then our amino acid requirement divided by the total volume gives our percent amino acids, etc. And then you determine your rate and rate your order. So in this example, we have a TPN for a patient, and we've determined they need 2,000 calories, 95 grams of protein, 1,680 mils of fluid, and we want to get 25% of calories from their from fat using 20% lipid. So we've done the first steps, determining energy and protein. We've decided, yes, this person's going to be on TPN maybe longer than 7 days, and so they're going to need IV lipids. And so and we know the calories provided by fat, so we're going to subtract that goal from the fat calories and from the lipids, which is a total of 880, and then subtract that, and that means we're going to need 1,120 from dextrose. So 1,120 calories divided by 3.4 calories per gram gives us 329 grams of dextrose. And if we're going to, let's say the MD says we have 1,680 mils, well, we will take that 1,680 mils and we will determine the concentration. So in this case, going back to our slide on protein, sorry about that, you would take your 95 grams of protein divided by your 100,680 mils. This is your amount allotted to your 2-in-1 solution, and that gives you a 5.6% amino acid solution, and you could just round up to 6%. So that's 6 grams per 1,000 mils, 60 grams per liter, and you're going to have a little bit more than a liter, 1.68. And then the dextrose, again, you take your 329 grams divided by 1680, you get a 19.6% dextrose solution. You just round that up to 20%, and then it's 200 grams per 1,000 mils. So you give yourself these final volumes. You say 6% amino acid, 20% dextrose, and 1.68 liters per day with 250 mils of intravenous lipid emulsion. And you can also express that at an hourly rate. So you could write D20, 6% amino acid at 70 mils per hour with 20% intralipids at 10 mils per hour. And that is all we have to say today about that.